Now let us study the trend of electron gain enthalpy. See, we have seen that it depends on the nuclear charge, atomic size, and of course the electronic configuration. The electronic configuration will always create some certain exceptions in the general trend, so we will not consider it while giving or while actually studying the general trend. So it is mainly the atomic size and the nuclear charge which affects its general trend. Now, in a period from left to right, what we find is, since the atomic size decreases, what we find is the electron gain enthalpy increases. I'm talking about magnitude. If you want to consider in terms of sign, it will become more and more negative. So the delta Eg H naught electron gain enthalpy increases from left to right in a period. Why? Because atomic size decreases and nuclear charge increases. So that's why what we find is the electron gain enthalpy increases as we move from left to right in a period. Now let us study this thing with an example. Like we have in the second period lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. We know this is a noble gas, not going to accept this. Nitrogen is having positive value as I have explained it to you, and beryllium also has a positive value as I have explained it to you. So largest in these is in terms of size, and the nuclear charge is least in case of lithium. So what we can write is that lithium is the one which is having the lowest electron gain enthalpy. But remember, this is not correct, because we know we have positive values of these two as well as of this. So out of these all major eight elements of the second period, what we find is the lowest is in the case of neon, then we have in the case of beryllium, then we have nitrogen because it has a positive value. Then we have lithium, then we have boron, and then we have what? Carbon, and then what we find is it is basically the oxygen. I can write here oxygen, and the largest is in case of fluorine. Now these three comes before initially. The reason is they have what? Positive values of their electron gain enthalpies, and the most positive is in the case of this noble gas because it has a completely filled valence orbit, octet is complete, followed by beryllium and nitrogen, because in these two cases what we find is definitely the nuclear charge of the nitrogen is much more than beryllium. So this is what is the general trend in terms of the second period elements. Now let us see this case in case of a group. In a group, what we find is the electron gain enthalpy. I'm again talking about the magnitude decreases from top to bottom. It decreases. Why it decreases? Because atomic size increases and nuclear charge becomes less effective. That's why as a result what we find is that the inner group, as we move from top to bottom, as we move down the group, the electron gain enthalpy decreases. So this is what are the general trends. But we have exception to these. The exceptions are, what we find is that in case of 15th group, 16th group, and in case of 17th group, the elements are nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, arsenic, selenium, bromine, like this. Now, as I have told you, as we move down, what we find is the electron gain enthalpy decreases. But what we find is that the electron gain enthalpy of nitrogen when compared with electron gain enthalpy of phosphorus, what we find is phosphorus is having a higher value. In fact, the electron gain enthalpy of phosphorus is negative and of this one is positive. So remember, we are not talking about in terms of the magnitude or sign, sorry. We are talking about in terms of the value. Here the energy is spent actually, and here in this case the energy is released. So it is higher in case of phosphorus. Now similar thing we find is the case in case of oxygen and sulfur, that the electron gain enthalpy of oxygen when compared with electron gain enthalpy of sulfur, what we find is sulfur is more negative. The magnitude is more in case of sulfur than oxygen. So it is again the one which is actually having higher value. Then again, let's move further. Never think that fluorine is the one which is going to have the highest electron affinity. When we compare the electron affinity of fluorine with electron gain enthalpy of chlorine, what we find is chlorine's value is more negative, magnitude is higher. So it's again the same trend is repeated here also. Now what is the reason is why we have such behavior in group 15, 16, third period elements? The reason is because that these third period elements, in third period elements, the extra electron enters the bigger 3p suborbit. Therefore, less interelectronic repulsions. So they all have bigger 3p. Now all these three have smaller 2p. So extra electron will experience more repulsions in case of smaller 2p, and that is why the same thing is repeated in these cases. So what we find is that the element with the highest electron gain enthalpy or with the highest electron affinity in case of group 17 is fluorine, not chlorine. In case of 16 it is sulfur, not oxygen, and in case of 15 it is phosphorus, not nitrogen.